Okay, so once again, so if we plot the graph of lambda m versus under root c dilution, then for strong electrolyte it will look like this. As we dilute, as we decrease the concentration, then the molar conductivity decreases, and at one point it will meet the lambda m axis, which is considered as lambda m0, the molar conductivity at infinite dilution. And for this is for strong electrolyte, and this is for weak electrolyte. It increases rapidly because the number of ions increases, so it is a parabola kind of thing. So you can be asked which one is a strong electrolyte, which one is a weak electrolyte graph. Similarly, if we plot a graph of lambda m under root c, and one plot is for one, another plot is for where steep rise is there, right? So you can see lambda m0 will be more in case of which of the ions. If we consider two strong electrolytes, HCl and KCl, they are both the strong electrolytes. This is lambda m. Which one will have higher lambda m0 value? And there are two graphs over here. So how will you distinguish which graph is for which? So here if you extrapolate, this is lambda m0 here and this is lambda m0 here. Now if we consider this as KCl and this is HCl, why is it so? Because KCl will dissociated into K plus plus Cl minus. HCl will be dissociated into H plus and Cl minus. Whose conductivity will be more? Cl minus is common, so their conductivity will be the same. But if we look at over here, K plus and H plus, then H plus are the smaller, so they can be easily moved, and that's why the conductivity of H plus will be higher. That's why this one will be having HCl graph and the lower one will be having KCl graph. Understood? So this can be also asked. Once again the question asks like this: lambda m versus under root c. If one electrolyte is like this, another electrolyte is like this, one electrolyte is like this, identify the graphs. So if three solutions are given, HCl, NaCl and acetic acid. Acetic acid is a weak electrolyte, so it is this one. NaCl is this one, and HCl is this one, because H plus is quite small, it is having higher conductivity. So this kind of questions can be asked. Once again, if you are asked that molar conductivity is increasing with dilution, why it increasing with dilution, why it increases with dilution, then there are two reasons, right? You can also write down that lambda m is equal to K into 1000 divided by m. With dilution, K decreases and m also decreases, but m decreasing is more predominant, and that's why lambda m ultimately increases with dilution. In case of strong electrolyte, what will happen? NaCl gives Na plus plus Cl minus ions. These ions are getting surrounded by H2O molecules. That means solvation or hydration takes place. When they are surrounded by H2O molecules, they lose the attraction between Na plus and Cl minus. They are easily free to move, and that's why the conductance increases. While in case of weak electrolytes, what will happen? The number of ions per unit volume increases. The number of ions only increases, right? Not per unit volume, the number of ions only increases. As we dilute, as we pour more water, more dissociation takes place, and that's why the number of ions increases, and that's why the molar conductivity also increases. I hope it is clear. Tomorrow we'll do some numericals on it. So there are, I think, 4 or 5 videos. Watch them properly. And if there is some confusion about the cell constant, once again, I got confused myself. So if there is a confusion in cell constant, then cell constant is equal to L by A and not A by L, right? It is equal to L by A. And if you want to find out conductivity, kappa is equal to, now conductivity, what are we finding out? Let me just refer to my notes and I'll tell you. So yes, conductivity is equal to conductance into cell constant, right? So conductance into cell constant is known as your conductivity. So I hope all the things are clear. If not, then let me know, then I will just send you some notes which I made, and it will make the things more clear to you. Okay, so children, you had some problems with the electrolytic conductors, conductance and molar conductivity and stuff like that.